Okay, the problem states you receive a brochure from a large university. The brochure indicates that the mean class size for full-time faculty is fewer than 32 students. You want to test this claim. You randomly select 18 classes taught by full-time faculty and determine the class size of each. The results are shown in the table below. At alpha equals 0.05, can you support the university's claim? Completes parts A through D below. Assume the population is normally distributed, and we're given the table of data in order to use in our calculations. And one of the things I want to do is go ahead and blow this up so that we can actually look at this. And I want you to understand that when we're looking at this, this is going to be a hypothesis test, and we're looking at determining what our null hypothesis is and what our alternative hypothesis is. So we have H sub 0, that's the null hypothesis, and we have H sub A, that's the alternative or alternate. And remember that the alternative hypothesis is strictly a statement of non-equality. That means that it will either have a less than sign in it, a greater than sign, or it will be not equal to. In this particular case, when we look at this, we say the brochure indicates that the mean class size for full-time faculty is fewer than 32 students. When we say that, that is our alternative hypothesis because it is a statement of non-equality. In other words, the mean is fewer than 32. So by definition, this has to be our alternative hypothesis. Therefore, the null hypothesis can be rewritten as the mean is greater than or equal to 32. And so we make our choices from the multiple choice, and this is what we have right here. The null hypothesis, mu is greater than or equal to 32. The alternate is mu is less than 32. Now let's go ahead and go back into my stat lab, and we'll go ahead and we will select that. We will check our answer, and we're good to go. The next thing that we move on to is use technology to find the p-rule or the p-value. Now, as you can see, I've moved it over into my workspace, and we say we read use technology to find a p-value. P is equal to, and then round to 3 decimal places as needed. Well, what I want to do is understand that this symbol right here in my stat lab, that is a copy button, and it will copy my data set. And that's what we're going to do next. We're going to go back into my stat lab, and we're going to go ahead and point to the copy button, and it says click to copy table. You'll notice that I left click it. I will now open it in StatCrunch, and you'll see that my data values are listed in this first column. We're trying to find a p-value. In order to do that for this particular problem, we need to go back and understand what our sample size is. So let's go back into this, and let's indicate that we are going to find our sample size. The result of we randomly select 18 classes. So the sample size n is equal to 18. And that's what we're going to need to use in order to find or to perform our hypothesis test. We also need to understand that alpha is at 0.05. Since this is a sample size of 18, we're going to use a t-distribution. So that's something that you need to keep in mind as you're doing this. So we will use a t-distribution. And I will just abbreviate distribution. So now we're going to go back into my into StatCrunch, and as I said, we're going to use a t-distribution. So our data is already loaded in the table. Left click stat. We're going to highlight t-stats, and we are going to highlight one sample, and in this case we're going to left click the with data. We want to left click this, the column var1. we are going to make sure this radio button for the hypothesis test for mu is selected. We're going to go ahead and put in our null hypothesis, which is 32. And remember that our alternative hypothesis or alternate is less than 32, and that's what we're going to calculate on. So we will left click compute, and we get this table. And you'll notice that it's got the p-value right here of 0.0919. So going ahead and using our table, I can go ahead and say my p-value is 0.0919. Now remember, however, that we want to round to 3 decimal places as needed. And in this case, to round to 3 decimal places, p will be equal to 0.092. And that's what we're going to enter into my stat lab. And we'll put that right there, 0.092. Left click, check answer. And now we move on to the next set of questions. Part C, decide whether to reject or fail to reject the null hypothesis. You'll notice that my stat lab will list the 4 possibilities. So which of the following is correct? Choice A is fail to reject the null because the p-value is less than the significance level. Part B, or choice B, says reject H naught because the p-value is less than the significance level. Part C is fail to reject H naught because the p-value is greater than the significance level. And choice D is reject the null hypothesis because the p-value is greater than the significance level. So writing down the p-value once again, we see that the p-value is equal to 0.919 according to the table, and we did round it to 0.092, and I said 0.919, I meant 0.0919, and the alpha is 0.05, and we see that this p-value is going to be greater than the alpha. So p is greater than alpha in this particular case. And if p is greater than alpha, we will fail to reject the null hypothesis. So we need to make sure that we read and choose the correct one over here. Fail to reject because the p-value is less than the significance level. That's not the correct wording. Reject the null, well, we already decided that we will fail to reject, so that leaves us with choice C, fail to reject the null because the p-value is greater than the significance level, and that's what we're going to choose for our part C. We'll go back into my stat lab, we'll left click part C, we'll check the answer, and that's going to reveal the last part, part D. Now, since p is greater than alpha and we failed to reject the null hypothesis, we need to interpret the decision in the context of the original claim. Our first statement given here, at the 5% level of significance, there is not sufficient evidence to support the claim that the mean class size for full-time faculty is fewer than 32 students. So remember what our null and alternative hypothesis were as stated. We had the null hypothesis was mu is greater than or equal to 32. And then the alternative hypothesis, since mu is greater than or equal to, will obviously be a less than 32. So what we're doing is we are failing to reject. So we will fail to reject. And since we have failed to reject the null hypothesis, right here, part A says at the 5% level, there is not sufficient evidence to support the claim that the mean class size for full-time faculty is fewer than 32 students. Well, that is going to be the answer for that one, because our null hypothesis states that we're looking at greater than or equal to 32, and we failed to reject that. So we will accept statement A. Let's go ahead and explore the other ones. Part B says at the 5% level of significance, there is sufficient evidence to support the claim. Well, that's not true because we failed to reject, and that means the claim that the average class size is less than 32 is not going to work for this particular problem. And we can use the same logic for part C, or I should say answer choice C or answer choice D.